Alternate interior and exterior angles. Let's do another mini lesson like we did last time. And let's start the same way we did with our vertical and adjacent angles lesson, which is with this X. Little review from what we learned last lesson. And if you haven't done that yet, do that first. We learned that if we have two angles that are vertically across from each other, as in they have V's here and here, that they are congruent. They are the same angle and they're known as vertical angles. We also learned that if we have angles 1 and 2, like siblings separated by this just thin wall that you wish was probably thicker, these are adjacent angles because they're right next to each other. Today, we are going to see what happens when we have a new type of situation. So what I'm going to do is I am going to draw a parallel line to one of these angles. And you know that they're going to be parallel because I'm going to draw little arrows there. These arrows match, so then these lines match. They're parallel, meaning they will never ever touch. They could go on forever and never touch. All right. You'll notice that when these two parallel lines are cut by this other line is known as what's called a transversal, which sounds like a fancy transversal. Sounds like a fancy science word. Let's go get the transversal and figure out our experiment. But it really just means a line that cuts straight through parallel lines. It forms a whole lot of different angles. All right, so I'm going to draw some angles for you now. And what color should we use here? Orange. If we focus on our parallel lines, you will notice in these pairs that some, like 1 and 2 and 3 and 4, are on the interior of our parallel lines. They're between them. Whereas the exterior on the outside, like 5 and 6 and 7 and 8, are on the outside of the parallel lines. Or if this is like a force field in here, these are shut out of the dome. So that means that like 7 and 8 are exterior angles because they're on the exterior of these parallel lines, and like 1 and 2 are interior angles. Okay. The next thing to notice is that if we focus on this transversal here, like 8 is on the top of the line and 7 is on the bottom. Likewise, 1 is on top and 2 is on bottom. If they alternate within each pair, different sides of the transversal, as in one's on top and one's on bottom, then these are what are known as alternate interior angles and alternate exterior angles. And you'll notice that these angles, like our vertical angles, look the same. This 7, if we were to turn it around, it looks like 8. Same thing with this 1, looks like the 2. 4 is an obtuse angle like 3 is, and it turns out that that is true. Alternate interior angles and alternate exterior angles are both, that fancy math word again for equal, congruent. So just like the end of last assignment, we're going to have some SADME practice with some equaling angles to each other and doing some algebra. So make sure you have something to write with and write on. Make sure you have your calculator available, and let's dive in. I'm closing this beautiful picture. It really is beautiful. 3, 2, 1. Let's do it. All right. Diving in. Alternate interior and exterior angles. So here we go. We immediately have a picture similar to the one I drew. You're going to have to just assume these are parallel. They don't have a little arrow, unfortunately. But you'll notice we have 136 and 136. They're congruent. The question is, are they on the interior between the parallel lines, or are they on the exterior, the outside of the parallel lines? I can hear you screaming at your laptop all the way in the past when I filmed this video. Yes, it is exterior angles on the outsides. So the first one is alternate exterior angles. You're on fire. Oh no, I'm in my house. I need a fire extinguisher. And number 2 is, in fact, the opposite. It's now 140 and 140. They're on the interior between our parallel lines, so they're alternate interior. So number 1 is alternate exterior. Number 2 is alternate interior. Then continuing that vocabulary situation, if we don't have numbers that match, but we still have the same letter, and it's still in the same spot, or notice I could tilt my angles now. Now this one's on the right and this one's on the left of the transversal, and they're still on the interior. It's just turned sideways. That's still alternate interior. So sometimes that confuses people because they're like, wait, I thought you said one had to be on top and bottom of the transversal. It's true. It's just now that whole thing's tilted, so the top and bottom looks like the left and the right. All right. And it's good to continually have review from our other ones. We know that if 1 and 2 are making a right angle, a 90-degree angle, that just like a complement with no agenda or incentive is the right thing to do, 2 angles that form a right angle are complementary. Awesome. And we have a situation where these are not congruent. Instead, it's 139 and 141. Oh, let me use this calculator for the first time in a long time. What's 139 and 41 add to? 180. Oh, 180. That was that situation we had where it's twice as many p's, so it's twice as many degrees, where they're supplementary. They can also be called, as we learned last lesson, a linear pair, a straight angle to go along with supplementary. In this case, though, they want linear pair, a pair that forms a line. You win! What do I win? I guess 5 problems correct now. Then number 6 reviews what we did last time. Now we have the V's, and they're across from each other, which means they are also congruent and they're vertical angles. All right. 7 and 8 are the sad me problems I promised you. We have alternate exterior angles here because they're on the outside of our parallel lines that are beautifully denoted with arrows this time. And here we have alternate interior angles that are between these parallel lines. In each case, as we went over, we know that they are congruent. So for each of these, I can write them out with just an equal sign between them. And let's use a little sad me. Let's solve for x. Okay. 76 minus 34 is 42. The rabbit situation, we got to do the opposite. Divide those rabbits. X is 6. So as always, I just put 6. Never put the x equals, and you'll notice that because it says x equals blank. You just fill in the blank. Same thing down here. I have minusing again. So that would be 54 is 3x. Then dividing. Most of these really end up being like subtracting and dividing. There's not a whole lot of multiplying that comes in. So hopefully you're getting really good at this after the last few assignments. 54 divided by 3 is 18. So I've got 6 and 18. So I'm going to close this in 3, 2, 1, boom. So I could put 6 here. If you're zoning out and need to rewind, always feel free to rewind. The beauty of this being a video. And 18. And I want to show you real quick, if you ever doubt this, again, what makes algebra so awesome is that I can say, hey, what's 3 times 18 plus 21? Is that 75? And you can just prove to yourself, boom, it is 75. So I know that x has to be 18. So before I even hit check, I know that I'm correct. And I love that power with algebra. It's so cool. One of the reasons why I became a math teacher, honestly, to help people learn that power of algebra. I don't know if you feel like a right angle today. I don't know if you feel like a straight angle, if you feel acute or obtuse or however. But today, whether you're interior or exterior from a house or a school, I hope this video finds you well. Until next time, it was an honor and pleasure helping you through this assignment. And I look forward to helping you with the next one as well. Take care.